large language models. So we are using large language models to build applications, which includes agentic workflows, RAG applications, and LLM products as well. So this is a small intro about me. So today, let's see about this data, predicting machine faults and sensor data. So in general, this is a real life scenario where even I got a chance to work with this data set. So in industries like maybe food industries, maybe medical industries, maybe any chemical industries, we'll be having large machineries where one have to monitor it, how it is performing. Let's say if it is an maybe any chemical factory or a medicine factory, it needs to give us a component. So after the usage, there are many reasons why it can go wrong. Maybe temperature increases, maybe wear and tear. There are many reasons. So you have set a specific composition to enter or to print tablet or to disperse at each moment. So because of these issues, we might get a faulty output. It is quite possible because of machines. Those are made of all gears and levers. So they tend to have wear and tear because of the gravitation. So it is quite common in those industries who are dealing with the bigger machines. So how can you overcome this? Like if you know this such event is going to happen, you can go and check it. You can change it. So for that reason, there are many sensors placed. How it is going to affect, like the sensors track everything. How much the wear and tear is happening, like how much vibrations it is generating, how much temperature it is going on, how it is performing, is there any malfunction. So there are different sensors installed in across all the machineries in general life. So with that sensor data, there will be a loop where it triggers and sends a mail or any kind of notification for the person to check. So something is going to happen, so it is not going to work well. So here we can use this prediction model. Let's say I'm talking about a machine where we need to make sure that temperature should not cross 100 degrees maybe. So we are placing a temperature, we are placing a sensor which can sense the temperature and give us the output. Like it's a live thing. So then and there, like when the sensor can take the temperature, sensor detects the temperature, we'll be getting informed like this is the temperature, this is the temperature. So this kind of sensor system will be there. So once the temperature crosses 80 or 90, our threshold is 100. Like so, we'll be having a buffer of 85, 90 or something. So we can attend and we can change whatever things need to be done, or we can turn it off or whatever. So if this is not done, the machine can go like it can malfunction, or it can spoil. Like it can't work. It stopped working. It stops working. So this is the real-time example where sensor data or sensor things can happen in industry level standards. So I have a small data set where this is a data, as I mentioned, readings of a sensor at different locations, and each record represents minute level snapshot. As I mentioned, it is a live data. So metrics are collected including these data. So we are having temperature, vibration, voltage, current, pressure, humidity, sound level, and the load. So as I mentioned, there are many parameters to see if a machine is going to malfunction. So these sums up the statement what I'm saying. So temperature is one of the thing. Again, in general terms, there are many mechanisms, but in general terms, we can identify these issues by seeing temperature, vibrations, voltage. Maybe there might be any current fluctuations. So voltage may go up or may go down. If it is going down, it might not move well as expected. It might go up. It might fire away the parts. The pressure, maybe if we are as I mentioned, if we are getting a tablet stamp look, so the pressure plays an important role. The pressure is too high, we might crush the tablet stamp what we are getting. If it is too low, we can't make it as a solid tablet. Humidity, if it is humid, then it might become very wet and it can't hold the mold. Sound may also waste. Like if the wear and tear increases, the gears are not performing well, we can hear a lot of sound. And the load, how much load it is taking the entire machine while doing all these things. So these are the data set what we are having. So our target is variable where we are finding if it is an fault or not, if it is going to failure or not. So for this, as most of you know, EDA will be doing. So this is the main thing where we need to clean data. So when we are having a real-time scenario, the people who are providing data might not be aware of technical terms. They might not be who are into data science or data analytics. They don't know how to gather data, what need to be sent. So always data when we are getting is a raw format. It can be as raw as a string. It can be logs. So if you are writing any codes, we'll be putting logger statements, right? So there they might print every data or every value, which is encoded in different nomenclature according to the company norms, maybe company name followed by the error message and followed by the value, etc. So we might get log level data. So the first thing is pre-processing or gathering data where we can work on it. So if it is a string data, as I mentioned, if it is a log data, how can you do analysis? So what analysis we can give if it is an logs? Logs are nothing but a statement, print statements. So if we are having 1 lakh print statements, what are you going to do with that? So let's say we are having a log data as I mentioned. So anyone can guess like what can be done next. As I mentioned, we are having a 1 lakh log records of maybe machine or anything. It can be an application, whatever it is. So it is holding everything. As I mentioned, the company nomenclature, maybe XYZ company hyphen. This is the first record. For this record, we are getting this value and so on, date, etc. So the log will be in this structure. So we are having these records. So what can be done as a first step? Anyone can try.
Data extraction from the logs.
How? You're saying something? Sorry. How? Yeah, that is the main agenda. So if you are having that, what will be the next step? Just, converting it into structured data. Yeah, that makes sense. Once it is a structured data, we can work with.
It's
So
ED. It comes under ED and pre-processing. Is that?
yes. So basically, if it's a string, we can use regex to extract what are the keys and values. We can dump it into JSON. We can dump it into Excel, CSV, whatever it is. It can be structured. It can be anything, as you mentioned. It can be any data. So once we have data, which is structured format where we can use it for EDA, we can start working on it. So in real life, this is the scenario where we get a lot of issues because the data is not always unique. So when I'm telling about this log data, so there are cases where from log data we can only get 3 to 4 fields, not everything. But for our prediction or for our use case, we might need more data. So that will be in another format stored somewhere else. Because as I mentioned, people who are giving the data might not be aware of how to store data, or they are completely away from data analysis or data science. So they don't know how to store, how to extract data. So maybe there are folks who can write ETL pipelines instead of we going and seeing manually checking everything. So once they catch a logic, once they know how to transform the data into a usable format like structured format, they'll run some loops. As soon as we get a logs, as I mentioned, there will be a script which will convert, which will break, and which will return the terms what we need into a maybe database or maybe JSON or maybe text file, whatever it is. So that can be done using ETL pipelines, like where data engineering work comes in. So that is one more. That is one of the like pre-processing, like initial step what we can do here. And once we have data from logs, as I mentioned, we need to gather data from different resources. It's not always log, or it's not always a straightforward CSV. It's not always the Excel, because saving into CSV or saving into Excel is very heavy and time consuming thing, whereas compared to JSON structure or any other XML format structures. So those are very lightweight, can be easily shareable, is easily transformable, and it can be stored in very less memory. So when I mentioned as a log things we are saving, so to save these logs files in a file of like 100 1 lakh log records, it might take maybe 1 to MB. The same way, when we want to save this 1 lakh in CSV or any Excel format, it might take 20 to 30 MB. So this is the variation of saving the. So for our use case, we can convert them into CSV or anything. But when we are dealing with the raw data, it is not a structured data. It is like uh, at most unstructured data, we can say. As I mentioned, we need to gather, we need to clean, we need to map and see how we can link this log data with any DB data or any Excel sheet, any JSON format or anything. How we can link it, how we can map it, and how we can get the data. So there might be any unique ID, or maybe uh, date and timestamp. So let's say if we are dealing with any live data or sensor data, as I mentioned. So now I'm recording the data for 24 hours, let's say. So the day starts at 00 hours, day ends at 29 for 59, 24 hours. So if we are dealing with 1 day standard format, then we can use this, because this is in live data, we can't go back. So once the day is passing, the data keeps on increasing, we can't go back, we can't switch back. So here we can use this date and timestamp as a unique key to map any data from somewhere else. Maybe we need a manufacturer, or maybe we need a person who is in charge, like maybe who is there, or maybe voltage at that point of time, what is the electricity passing through. So to get this data, we need something unique to map with other DB or anything. It can be CSV, it can be DB, or it can be anything. So this mapping helps us map there and extract data. Once we get data, we'll do the EDM. Uh, so what are the basic steps? Like when you get data, what is the first thing you might do? Anyone can. So the data is structured now. So what is the next step?
Checking the stats.
Yes, first point is check if there are any duplicates or if there are any null values and drop them. Next, directly jump to correlation.
Visualization.
What about this? I'm just asking you in normal what is your approach? So what are the steps in EDA? Yeah, first step is null values. Next, what will you do with missing values? Okay. So is it always the right approach to do? Let's say I'm taking a survey. So I'm taking a survey in a street or in a city. So in that survey, there is a field gender. I'm asking everyone to fill the form and mentioning their gender. So male, female, these are the two options. Let's say out of 10,000 people in that state or in that city, we got 3,000 as male, 4,000 as female. So out of 10,000, we got 7,000 values. So what can be the other 3,000? How can you say it can be half of? Sorry? But if you are filling it based on the data, you are creating a data which is not true. It can happen. So in this case, if it is this sensitive, we should leave it, and we should introduce one more column as NA or any other things. So other big, because they don't want to reveal their gender. it is up to there. So this comes under demographic, like person demographic sensitive data. We can't impute this because we might accidentally create a data which is not true. So if we are creating such data and if we are giving insights or if we are giving the model to train, ultimately when we are dealing with the predictions, it might fail. The results what we get is based on the data what we are feeding it. So ultimately it might predict wrong. So imputing categorical values with the most repeated is a standard thing, but it is not always applicable. In real life, it is not at all applicable. If you are dealing with maybe healthcare data, their gender plays an important role. You can't imagine or you can't guess and impute. So that is the place. Like coming to this analysis and all, domain knowledge is at most important. Like once you know what to take, what not to take, or what we can impute or what we can omit, so that would be helpful. So if in this case we need gender so far, like it is a mandatory field, we need to deal with it, then we need to drop other 3000 values and do the analysis with whatever we have. Or if it is a criteria where we should not miss out all the records because there are a few features where which are important for our analysis, then we need to impute it with NA, which might in turn give us a new insight where these many people are having these values who are not ready to disclose their gender. This is one more thing what we can say. Maybe we are talking about income, maybe, let's say. So these many females are having this much income, these many males are having this much income, and these are the other people among all those whose income is this much, but they are not ready to disclose their gender. This is one more insight what we can achieve if this is the case. Where are we? Next step after cleaning, after imputing.
Visualization.
Okay, what kind of visualization?
We will see how the data is spreaded.
Mhm.
Like, is it linearly spreaded or not? We can use various like we can check by the variable
Okay,
how they are correlated or not.
okay. Okay. What is an outlier?
Like unwanted value, like it will not fit into the data, which is like not desirable.
Okay. So what you are going to follow the pattern of the what you are going to do with outliers if you encounter any? You are going to remove. Any other answers?
Formulas like E in this equals to 2.
Okay. What is an anomaly? Have you heard of this word? Anomaly. I'll give you an example. Let's say, as I mentioned, we are having a survey. So there we are recording age. We are having a age ranges from age can range any number. So we are having a only single record which shows age as maybe 72. In the survey, who are working professionals, we are taking income as I mentioned. So we are also recording the age. So only one record age was 73. What are you going to do with it? And you have all the fields for that. You have gender, you have income, you have everything. There is nothing missing, but the age is 73. Is it an outlier? Are you going to drop or is it an outlier? Why? Why can't age be 73? Why can't a person at 73 work? Yeah, but still it is a valid data, right? We have gender, we have income, we have everything. And that is no rule that age should cross this number and person should not work. So as I mentioned, again, domain and the data like where it is plays an important role. Here we can't treat this as an outlier. Let's say maybe a human error or anything like while entering, if the age is 107, or 108. And still you are having all the records. You can drop it. Maybe 173. Instead of 73, he's adding 1. Or maybe instead of 17, he's adding 3. That we can remove. And coming to anomaly, like outlier and anomaly, these are two different things. Outlier is not completely suspicious record always, but whereas anomaly, it is a suspicious record. So outliers are not meant to remove always, but anomalies we should remove. As I mentioned, the 173 is what it is. It is an anomaly, not an outlier actually. So 73 age can be an outlier when you are having a data where most of the records are the entire data age is cut off maybe at 45 or 50. So there is a long distance, like there are no data points. You can consider it as an outlier, but it is a valid data. You can't drop it because this is completely valid. Like in general also, he's working, he's having like this income and all. So we can continue. This might skew our report or skew our analysis, but still it's a valid data. This is how it is.
Then we need the generalization.
Why?
So, we want to predict the future things.
Okay.
So these may create.
So what if in future you are going to get a 71 or 72 age person record?
101. Not.
Then you are going to lose it, like then you are like not ready to predict it.
Then we need generalization. So
Sorry.
then we need to bring the generalization output.
So for analysis, for going reports or anything, there is no need to remove this. This is what I'm saying. This is one of the insight you are getting, right? So out of these many, this guy stands at 73, still is working, still is earning this much. He's doing this. This is one of the key insight what you can provide with that data. So like outliers are not always meant to remove. So they
I have a question.
Yes.
Okay, if it is age, we will know whether it is like anomaly or outlier. What
Yes.
if it is a salary? Then how we will know it's anomaly or like outlier?
Yeah, again, generally, let's say our salary ranges between maybe 10,000 to 2 lakhs, but a person is having 10 lakhs or 15 lakhs. Still, it is
Okay.
an valid still, like, because there is a chance a person can have 15, 20 lakhs salary, right?
Mm-hmm.
Then also it is not an outlier. So here we can say out of these, this is one more insight, like out of these many records or out of these many things we gathered, this is what how it is. Like the minimum value is this much, maximum value is this much. So most of the people lie at between maybe 5 to 6 lakhs, and the only this person lies above 10 lakhs. This might give you a different average or anything, but this is like not a value where it is suspicious activity is happening or suspicious for the data to
Okay.
completely omit this.
Okay. It can
Maybe
be it comes under outlier, you mean?
it can be outlier, but it is not mandatory to remove it
Okay. Yeah.
based on the story what we are telling to the audience. Maybe there is an issue, there is a chance where person might enter his salary as negative, and we are like we don't have any clue. It is like 5 lakhs or 10 lakhs. We can say maybe instead of adding 5 lakhs, is like we just by mistakenly added as negative minus 5 lakhs. If the salary is minus 452, minus 252, whereas our salary starts at 10,000 or 50,000, but this record is showing as minus 450 or minus 650, then you can remove it. This is like not at all fitting anywhere in our value as so it is not ideal that a person can have minus 450 rupees salary as well. This makes sense to remove it, right? Yeah, that's what the difference is. So as I mentioned, like in healthcare, we are not allowed to impute any data. As I mentioned, it's very sensitive data. We should not impute or we should not do this median. We need to do how it is, like this is how the data is. We need to work on it. We need to do analysis. We need to do predictions. How the data is. We are not allowed to impute the data. Yeah, so pre-processing is done, visualization is done. So with the visualization, you are going to say this is how the data is distributed. These are the things what we can say
Sir,
how data is
I have
spread.
doubt.
Yes.
Yeah, how do you identify anomalies? Like if you have a age of 73 and the person mistakenly entered 73, but he wanted to enter 53, how do you identify that? We cannot directly classify 73 as anomaly, right?
Yeah, but this fits our case, right?
Yeah.
So that is a human error. As I mentioned, if it is a minus 53, if it is minus 1, or maybe the age is 6,
Okay.
we can
Like
remove it.
if
23
the
still makes sense. We can't go and cross verify if the person who taken the survey as it is right or wrong. So we are doing analysis here, right?
yeah, so how do we like we cannot verify directly in person? So how do
Yeah, we need
we
to work it.
we need to verify with the person who given the data
Yeah,
or
you can do that as well. If you are working for a client, you can go and cross check with the client.
yeah, okay, okay.
So finally, outliers and then what are more.
As I mentioned, depends. So if 73 is an outlier, there is no point of removing it, right? Depends on scenario, depends on the type of data, depend on the domain. What information we are going to show to our audience. So yeah, as you mentioned, different types of analysis. We are doing univariate, bivariate analysis. See how it is related to the target, how it is affecting the target variable, how much weightage it is giving to the target variable and all. So we do this kind of analysis usually. So far, any doubts? Anything you want to ask me regarding this or anything else? No one? Yeah, so this is the basic example I want to show. Once we have all the necessary import things like packages, I'm just reading the data, seeing what are the different columns present in here, seeing the information of data. So this is our target. So how many faults and how many things which are not in a fault thing. So these are the distributions. These are the box plot where we are mapping it across the target variable and see how it is affecting, how they are actually related. Okay. Coming to do anyone know this standardization and normalization? So why do we do standardization? When do you do normalization? What are the differences? So let's come from starting. Like what is standardization?
Comparing two different data sets on one screen.
Like, so what is the main motto of standardizing the data? Why do you do?
We are comparing the data.
What data? No, I didn't get it. So this is also while before preparing the data to model, we generally standardize data because as you mentioned, data in a table what we are trying can be in different scale. Let's say age, salary. So the age can vary from 10 or 15, depends on the domain. Can start from 0 as well, and then go up to 100 again depending on domain. And the salary also it varies. Can be crores, it can be lakhs, it can be thousands. So when we are directly providing this data to the model, as the model treats everything in like numerics, no, it can't operate with the categorical or words or strings. So when we are sending the data to the model, it can think the salary is having more weightage and age is having less weightage, it can give more weightage to the salary. But it is not the case here. The age column says a different story. It comes for a different aspect, and salary comes to different aspect. We can't give more weightage to salary, and we can't give less weightage to age. So to handle this, we will be standardizing this in a single scale where it fits into maybe -1, 2, 0, 1, +1, and we just pass it to the model before training. So that way we can handle this biased outputs. So these are the few plots what we can see, but it is not mandated to stick only with this. You can check different analysis. You can do different analysis. Like you can compare this with across this, how it is varying this, how it is dependent on that. Maybe how these two features are helping the target to move up or move down, or maybe something like that. You can always play and see how it is affecting. And also the standardizing, like if you are standardizing, what is the effect of the model? If you are not, what is the effect of model? If you are doing this pre-processing, how it is affecting the model, what it is giving the model when you are going to train it. And every time whenever you are dropping a column or imputing a column, imputing a record or anything, make sure you justify that. So what is the reason behind you are doing that? So if you are plotting this and if you are saying these are these values, like what is the reason of you plotting that and what that plot is explaining? It's not always that I need a distribution curve and I need a box plot. No, but what actually it is telling. It's not always that you should stick with the box plot. There are many different packages apart from Matplotlib or Seaborn. There are many. Try to experiment, try to research, and try to see how it is affecting, how good it is showing. So that is the main difference. Yeah, so these are the basic distributions what we can see for these values, how it is varying, distribution of temperature, the vibrations, what the sensor have recorded so far, and the voltage I mentioned, current, the pressure what the sensor is capturing, humidity, sound level, and the load. And this is the box plot for the load in what range it is. So coming to this bivariate analysis, as I mentioned, how a particular feature is affecting this. So this is the temperature versus fault. Like if the sensor is going to fail or not. If you can see, this is the temperature distribution for this. As the temperature is coming high, the box is like tilting towards a riskier side. Same with the vibration. So because when the machine is working properly and it is in proper condition, there won't be any vibration. Once it starts to wear and tear, vibration increases, chances of fault also increases. Same with the voltage and current. So it might not always the same. Based on the data what we collect, it might vary. Let's say we are having a data from January to December. So we don't know that there is a change in machinery, but we have data from January to December. We have two batches, like maybe January to May, one batch, and May to December is another batch. So the voltage or current for the two distributions might vary, but output might not vary because, as I mentioned, they changed the machinery, which we don't know, but we are doing our analysis. So because changing the machinery, machine A can hold the voltage up to so limit. Machine B can hold the voltage up to another limit. So if you are doing a combined analysis, it might give you a wrong perception. And if you are switching the machines and if you are seeing this might be the voltage what we can do, it will ruin the machine. This is one more thing what can go wrong. Yeah, this is one more plot what we can show. And like you can think of any plots what you can implement here and tell me what are the other possible plots here. You can think.
Linear.
Okay. Huh? Sorry. For what? You try it and see how it is showing. When you got this assignment, you just experiment it. So most of the part when we are dealing with modeling, most of the time we spent in experimentation and see how the results are. Coming to machine learning models or coming to large language models, everywhere the funda is same. So the more you experiment, the more you change the values, the more you change the parameters, you will get new things to see. And based on that, you'll switch back and you'll change. You'll switch back and update the values and see how the results are, how it is going to work. So, okay, what are the metrics do you generally use for validating a model if it is working good or bad? Maybe for classification. Hmm? No, I'm talking about matrix validation, metrics to validate the model. Okay, yeah. Okay, what is confusion matrix? What it is, what it tells, like if you are aware of it.
Like the outcome we get, which is good for us to is good for us to possible. Like there are two errors in
So, what is the metric you calculate? Accuracy,
accuracy.
Precision accuracy.
Precision F1 score.
recall.
Recall, yes.
So, there are cases where we need to change data such that we are targeting the recall always. So, can someone explain what is recall? Maybe formula or anything. Recall. Okay, when we are classifying something falsely into negative is recall. Let's say
Data.
falsely classifying it into negative, but it is not negative action. Let's say, as I mentioned, coming to healthcare sector. So you are given a task to classify if the person is affected with cancer or not. So you are given maybe genome data, maybe SNPs and DNA data of the person. So if the person is affected with cancer, the pattern changes in all the genomes and cells. So if you are classifying the data, the person into not affected, but he is actually affected, what will happen? So that is where we mess up everything. So it's in healthcare, this is more crucial. You can flag a person, healthy person as a cancer affected person. Maybe he can run a couple of tests and get a validation that he is not affected. But you can't miss out a person who is actually affected and you can't map with him is like he's not affected. So it's not always that whatever we see accuracy, sensitivity, specificity, yeah, we need to stick with that. No, but there are things there are places where we need to add bias and we need to improve specific metrics so that we should not go wrong. So coming to maybe telephone churn, like let's say what is the percentage of people who is going to port from X network to another network?
Mhm.
So that is one case where we are flagging a person who is not going to switch, but we are flagging and we are continuously calling or we are giving some offers or anything. So here we need to really filter down or narrow down our analysis such that we are actually identifying a person who is ready to switch from this network to another network. So this is one more case where we need to play with this metrics bias.
I think they are called type 1, type 2 errors, right?
Yes, type 1, type 2 errors. Exactly.
So how to deal with them?
You need to tweak the data. You need to make data bias.
Okay.
Yeah. So as you mentioned, this is the heat map where you can see how it is related. These are some of the distribution pair plots to see how the data is. Yeah, once the data is ready, we can do the modeling and see how the metrics are. If it is not fine, go with another model and see how it is. We prepare the matrix, we prepare the ROC curve. Yeah, this is what you can do. So what is AUC? ROC curve. What is its significance? Can someone explain the working of logic regression? What happens behind logic regression?
The generalization output is dependent on only single variable or highly biased towards any one feature. The feature which we are giving another is not learning from the model, not learning from the feature remaining. So we add some L1 composition to the highly weighted one to decrease weight on
Logic regression.
first.
Any questions you want to ask me? Anything? I'm open for discussion. Anything apart from this.
If you have data of the age between the normal age of age is 42, if you are given, and the salary is between 2 lakhs to 10 lakhs. If you have a data point, like the age is 73, like and the salary is like 1 crore, then it will become outlier or not.
No, you say, is it valid that a person can earn that much or not?
But based on we don't know about the practical thing.
So that what? So if you are dealing, if you are dealing with this domain where you are doing a survey of people who are earning, who are into IT field. So in this domain, in this field, now you have the domain. So now what it does it fits our problem statement? Does it fits our scenario or not?
We can check about
Yeah. So as I mentioned, this is sensor data. So we are dealing with these values. Let's say we are dealing with maybe temperature. It is a mechanical machine which runs with electricity and all. It's a machine, mechanical machine. So what if a value where temperature is showing as -60? Exactly. So why? Because you don't know anything. But how can you judge it is invalid record?
based on our data.
Exactly. Because the data is related to moving machine parts. It is not possible to record temperature at -60. It doesn't fit anywhere in our data. So in the same case, as you mentioned, if a person at 73 who is working in IT, you are talking with these earning and all things. Is it possible or not person to earn 1 crore? It is possible. As I mentioned, if the same criteria, maybe if the salary is entered as minus 450 rupees or minus 580 rupees or minus 3000 rupees.
Then it will contribute.
Exactly. That's it answer.
Okay. I have a question. When you see the data set first, so your focus is on the target variable or like the independent variable, how what you look. So when you visualize the data, which like maybe based on this data set only,
So
how you
my
draw.
approach will be I'll see if the data is balanced. Like I'll just see how the data is, like how the target variable it is skewed or it is imbalanced or it is having any weightage to yes class or no class. Then I'll start looking for different columns what it is showing. And always in real life when you are dealing with this data set, there is a high chance like you will be provided with a data dictionary where it explains each and every column. So timestamp. So what is
Okay.
timestamp? Is it talking about machine or sensor? It is a normal metadata which is nowhere related to the data what they provided. A machine ID, location, like what it is showing. From which like here the location means location can be anything. In our context to this, like it doesn't really say something about the data what we have. So we are talking about temperature. So now here temperature means sensor temperature in this field. So there can be another field temperature, but that might he might include a temperature metadata where the weather temperature is, like if it is summer maybe 36, that can be the case. So you will be provided with a data dictionary where it explains what feature is, so how it is extracted, what it is taken from, what you are doing going to do with that.
Okay. If you don't understand any variable or like maybe unnecessary variable is there, you drop it or like you just.
Yeah, we'll check how it is related with the target variable.
Mm-hmm.
If it is really helping or it is really providing weightage to the model overall, we can use it. If it is
Okay.
irrelevant, we can drop it. So the main focus is to predict, right? So if
Mm-hmm.
it is really providing weightage to the target, it's better to keep it.
Okay. Do you have any example for the regression?
Means
Like the regression problem where you like this is classification, right?
uh, so so I worked with a client where we provided with insurance data.
Mm-hmm.
So here the idea is to reduce his workforce. So what happened is he's an insurance company from UK. So he's having different what do you say sources where he is posting its advertisement, Facebook, Google, etc. So there are a lot of queries coming for him, but the people are not ready to buy the premium from him. But his team is spending calling all the customers like overall like daily. With the workforce of 100 employees, he is making sure he's calling each and every person who is coming and approaching and checking if they are going to buy the premium or not. But ultimately found out that there are very less customers who are ready to pay the premium. So this is our use case. So here what we did is we got some 350, 450 variables columns. As I mentioned, most of them are metadata, which includes longitude, latitude, where the person filled the form from, etc. So
Mm-hmm.
after going through the documents, after going through the data dictionary, we started dropping the columns. So we ended up getting 45 columns. In that 45 columns, the main key columns are age because the premium, the
Mm-hmm.
insurance premium always depends on age.
Mm-hmm.
So age, income, occupation, etc. These are a few fields what we finalized. So we started working on it. There are many things we needed to clean up. As I mentioned, processing data is important. So these columns are like not the straightforward columns. As I mentioned, we got few from them, and we also used to get few confidential things in a mapping state. Let's say they don't want to disclose maybe ethnicity of a person.
Mhm.
So they have these strict rules. So for that, what we were given is ethnicity is coded in 1, 2, 3 till 30 or 40. So for that coding, we have another mapping where we got an Excel sheets showing that 1 means this, 2 means this. Again, we need to map back and see what is the actual ethnicity and see how distributed it is. And this is also having many null values, many columns where they mentioned others. And
Mhm.
also, let's say uh, if you are mentioning maybe African or something, people are not writing it as is. Few people are writing A as capital. Few people are writing every letter as capital. Few people are writing every letter as small. And
Mhm.
there are spaces at the end, spaces in the beginning. So this is how the data state was. So
Mhm.
the data cleaning includes this as well. You need to remove trailing spaces. You need to remove all the spaces. You need to convert everything into a single case so that you will have the actual value codes. Or else you will end up getting three different counts for same the African word. Maybe one with capital A, one with small a, one with the space at the end. So this doesn't show any what is this doesn't have any weightage to the target to
Target value.
feed it to the
Mhm.
model. So this is one step where we need to work hard to clean the data. So this is one column what I'm mentioning. There are many columns such. So there is one more column called as source, like from where did they hear us?
Mhm.
It is mentioning like Facebook, advertisement, friends, Google, etc. So again, Google, everyone writing some as capital, some are keeping four O's in between instead of two. So there
Mhm.
are a lot of things we need to take care. Once this cleaning is done, we started dropping the columns, we started dropping the records and start working on it and
Mhm.
see which are correlated, which are not correlated. So we also got an update from client where he wants us to include few columns what he thinks as important according to their domain, but which we are not including in our model building. So once we got those features, we created a model using 70 features.
Mhm.
But the catch is the model what we built on 45 features is giving the same metrics when we are training the model with the 70 uh, features.
Mhm.
But which means the other 30 columns what the client was mentioning doesn't give any weightage while predicting this, because as I mentioned, in insurance domain age is more age is the main criteria. Like if you cross
Mhm.
your 70 and if you are having any illness or anything, no one is ready to give you an insurance. So in such that in this domain, in this thing, the client provided columns doesn't give any weightage. So this is one thing what you can see. So when we build a model with 45 columns, it is fine. But when we are giving the model with a 70, then also the same value. So it is not necessary to feed all the values to the model, because in future we might get different values, or we might have a different spread of values in those 30, which might affect the performance of the model. And here we dealt with a lot of imbalances. Like we used to have a 70% male, 30% female data.
Mhm.
It's the main catch what we need to. So when you have imbalanced data, what is the approach you need to do? Any idea, anyone? There are data balancing techniques, smart analysis, AdaBoost, etc., which will add some synthetic data and boost the data which is having less number, and it makes sure that the data is having both balanced data. So then we can try the model. So in our case, we tried many models. starts from regression, everything. So here we didn't classify the model. Actually, this is supposed to be classification, but the client needs a score. So he gave us a threshold where we need to score if the person is how much chances if the person is going to buy a premium. Let's say 70% potential customer, 30% potential customer, 20% potential. So this is the way how we want it. So what we did is we didn't did as like classification, we did it as a like continuous variable, and we gave this score like ranges from 0.1 to 0.9. So based on that, based on the threshold what he gave, if the score is less than 0.3 or if the score is less than 0.4, we are classifying it into the person who is high potential or else it is low potential. So with this, the client can narrow down calling to the person who are more potential instead of calling to each and everyone. So that is the main idea. This is a real-time problem actually. What I work with.
I'll explain like what we are doing to train a model. From there, you say like what are the steps to improve. We're taking a data model. From that, we are giving the null values and everything. After that, we are seeing the correlation by checking the correlation by using feedback. From that, we are taking the features which are highly correlated to the like target. From there, the features we are checking the interdependency which are like. From that, we are removing the features which are very highly correlated. We are taking the remaining features and we are taking a scatter plot. And from there, we are deciding the model. And we are trying the model on best feature among these things we have taken. Is this the correct model or we have to do anything else?
Yeah, let's say if you are not satisfied with the score, maybe if you are getting accuracy of 60% or 30%. Yes. So experiment with different model. So it's not that every model should work with every data.
But retraining the model with another, like in real time, it takes much more. It's not correct to.
So as I mentioned, there is a lot of experimentation going on, right? So without you taking a chance and without you running the model, how can you say that it is not going to work well?
Observing the scatter plot, the way and how the.
So then there is an issue with data. Maybe data is imbalanced, or maybe you have very small data. If that is the case, we need to expand data using synthetic data. So there are many techniques to increase the data count or balance the data, providing or say adding weightage. So there are many techniques. So it's not like that you should stick with it. Let's say if you are talking about regression or any model building, try to see what are the different parameters, what are the different things you can do for that model.
We are on the scatter plot of the features we took. One, we are getting the continuous distribution value. We apply the regression value. The remaining graphs, we know the features it getting a classified like classified like data points we are getting. It's not continuous. One, we are getting the continuous data points, and remaining we are getting the classified. At one point, it's going and which model we have to.
So what is the target you are going to predict? Yes or no, or price is a continuous thing, right? For continuous thing, what are the
continuous thing? We put one feature it is being the continuous distribution.
For continuous model prediction, what is the approach?
Going for linear regression decision.
Exactly. So as you said, let's say you are going to predict a price of maybe say something, let's say anything like vegetables, fruits, or anything. So for that, in general, like forget about data science, forget about data. So for you to put a price for your vegetable or fruit, what are the things you will consider? It is not always sell. So if you are selling it for 10 rupees last month, if you are going to selling it for 15 or 20 rupees in the future, what are the general things you consider? What are the general things you consider to put a price for your product?
Quantity, the quality,
and the spent like what the amount spent by you, right? Temperature, etc.
Yeah.
So your question is features are not continuous, but the target is continuous. Yeah, how it is affecting your model? Example I'm telling. If you are going to predict the price of your product, let's say what are the let's say you are having an ice cream unit.
we train a model.
I'll just give a normal example. You just tell me. we are talking about sales. How many sales, like how much sale you are going to get? Like maybe you got 5,000 rupees last month, 10,000 rupees before that month, 4,000 rupees before that. So you are going to predict what is going to happen. Like this is also continuous thing, if I'm not wrong. So to predict this ice cream sales in general, what do you think are the factors dependent? Season. Temperature. So temperature is a continuous variable, or it can be fixed. Let's say I'm binning it, maybe 10, 20, 30, or 40. And he talked about season. So season in this, we can consider the month, maybe month number 0 or 1 or 2. So it is not exactly. So what happened is, if you are having a record, if there are 10 to 15 records and you are having a target, these create a pattern to get this value. So if it is summer, if the temperature is 40, if it is in holiday season, if your ice cream unit is placed in a society where temperatures are too high and there are many people, many children around them, then the sales are 10,000. Coming to the second thing, if it is a rainy season, if the place where you are selling your ice cream unit is not in a place where there are children, maybe it is in front of an hospital or somewhere around city outskirts, and temperature is very less and chance of raining, etc. So then the sales will be low. So it doesn't matter that if it is a continuous variable or not. So it shows a pattern. So we are training the model with the patterns. So if this is the value for column A, column B, column C, then the price is this. If this is the value for column A, column B, column C, the price is this. So what is the value if the column A, B, C is this, and what can be the price? So this is the general thing what happens.
One feature is continuous thing.
Okay.
Many features are non-continuous. It's a class-based thing.
Okay, so
Do you have to include these features in my?
yes, you need to. So without temperature, without month, how
When
can
we use these features in our model, we are getting this answer. But if feature is not continuous, how can we use in a regression?
So that is feature, not the target, right? That is not the target you are going to predict, right? So the prediction thing is continuous. So that doesn't mean everything should be continuous. So as I mentioned, like month, etc., temperature are there. So these play really a key role. So forget about model for some time. You just talk generally. Without knowing the temperature, without knowing the month, without knowing the locality, how a person can judge if his ice cream sales are going to high or not in general. So it should not be continuous variable always. So you try to experiment with it. Maybe there are very less data, but data is not scattered well. So maybe there are chances you are having 100 records. Every sales value is 5,000 or something around that. So and the data what you should have is always diversified. So there are chances where you can see sales as less as 0. There are chances where you can see sales as high as 10,000. So if you are providing the data to the model where your sales are around 8,000, 10,000 always, but a scenario comes where it is tend to have sales of 2,000, but you never taught your model how a pattern of 2,000 looks like, because you are always giving the model where the patterns are 8,000, 10,000, 8,000, 10,000 or 9,000, but you haven't give any record where the 2,000 pattern looks like. How can it predict the 2,000 model? Exactly. So it can't perform well.
Like, what is the general approach to
Data should be diversified. Data should be very much diversified. Data should not be less quantity. Data should. So with these results, like the output what you are saying, it is saying you something where there may be n number of chances. Like you need to narrow down everything and see what fits well. There might be a chance where you are providing less features, which means these features are not enough to give accurate result, or maybe there is a redundancy, same repeated features which is not adding any weight.
When we look out these features starting by seeing the map, and which are highly correlated, we report in, and which are highly
correlated with target only.
So that's what I'm saying. It is not only one thing you need to stick with.
Yeah, that's
How diversified your data is, how many data sets you are using, how is it balanced or imbalanced, like how much. Let's say if you are talking about the continuous variable, I'm telling about sales 1,000 to 10,000. Maybe you bin it for 3 to 4 bins. How much of data is there in each bin? How many different patterns it is going to learn? How many features you are using? If you are removing the features, is it affecting the output? If you are adding any features, it is affecting the output. Have you checked the different imbalance classes, or maybe feature like you can switch and back forth to the features like parameters inside the model. If you are dealing with random forest or distances, you need to play with this grid search CV. Are you changing those? If it is if any of the feature or any of the target is skewed towards one side, is it biased, or it is really properly distributed? There are many things. You want to start down, note down, see how it is missing, what is not correct, narrow down and see what it is happening. If there are very less records also, it might tend to give the less accuracy and all, because it don't have enough proofs. It don't have enough patterns to see what it is performing. So it is not always the correlation or anything. There are n number of things, as I mentioned. Even I mentioned many, very few of many. So as I mentioned about the insurance thing, we used to get accuracy of 40 to 50, not more than that. That's what. But we could achieve around 70 to 73 doing a lot of research. Like most of the time spent on this project is on research and experimentation, nothing else. So the data what we have is the data what we have. So the client is not ready to provide more data because it's a person data. So in US, UK, it is crime if you share the demographics. So that is the data what we have. There is no chance to increase data. So we just like deep dive into the models, what parameters we can tune, what things we can do it manually, what things we can change, where to have weightage. Uh, Even we added feature wise weightage to the model. If there are 30 features, we are providing this feature should have this much weightage, this feature should have this much weightage, then we are training model. So this also we have done.
You wanted doing bias.
Yes, that's what. It's not always that client is ready to give you more data. So maybe in future when the model is deployed, there might be a lot of data where we can retrain the model and see how it is. But in this case, this is the data.
Once we train the model, how can you know that?
And again, so it is not hard, fast and rule that you should not add bias or you should not do this unless until you are not creating a record or you are not or so manipulating the record what it is as is, you can do anything. So you have that option to add bias or add weightage to the model. As I mentioned in this insurance, more weightage is given to age. Exactly. If the person is providing his mobile number or I don't care. Exactly. If the person is from this place or not, we don't need. So exactly, we don't need this weightage to be equally distributed, right? So that is what maybe in your case also that is might be happening. So there are features which are getting equal weightage, which are not relevant for your model to predict. There can be a key 1 or 2 features which are really important for a model to predict. So if we start talking about this, there are n possibilities.
Last, like, how can you know that is highly related to one feature and when we have to count down research?
Experiment.
Or
Experimentations. Add the weightage, see how it is performing. If not, decrease it. Add one more variable. If not, add one more or remove all. Add new. Experimentation. That's what experimentation. Trial and error. Sorry.
feature is not bad. What it is important is
Classification. If it is in bias, so what is your target?
target is not coming,
Okay, then
but feature is not coming.
still fine.
Can use.
Yes. Yes. Until unless it makes sense, why should not use? As I mentioned,
Is classification. Think when our feature is classification, then how can we draw a line or anything to get
bin it. Binning.
only
No. So if you are having a continuous variable, maybe it starts from 0 to 100. take 3 bins. 0 to 30 falls in this bin. 30 to 60 falls in this bin. 60 to 100 falls in this bin. So there are only 3 categories now. Now it is no more continuous. You are not missing out anything. You haven't removed anything. You didn't change anything. You didn't added anything. You didn't manipulate the data. You just binned it. This is one of many approaches. Unless it is adding weightage, it's not required to remove, or as you mentioned, it's a country is not giving anything. Try this. Because you are not doing any changes in the data, right? As data is changing, we are doing this.
What is your generalized way to approach it?
I can't say any, this is a generalized way. As I mentioned about this insurance thing, these are the things what we encounter. So later I was into health sector. That's why I can give many examples where I dealt with these genomes and DNA sequence. So there you are not allowed to tweak anything. So once you open the DNA, you are going to get something around 3000 to 4000 columns. You are not supposed to drop anything. You are not supposed to add anything. So the approach there changes. The approach in here changes because I have a full access to change the remove or add the columns or whatever it is. But here the thing is different. So if we are not getting things, we approach the client. He might tweak some DNA sequences or the cells what he is providing. He might add some. He might remove some. But this is how it is. So there is no generalized thing because based on the data, based on the approach, based on the requirement, what we need, it changes. The same approach I can't apply with for the healthcare, right? For the insurance, right? When I'm having 350 features, it is time waste for me to use all 350 features. Doesn't make any sense. So if it is a generalized thing, I can't apply the same to the data where I have genomes, RNA sequence, DNA sequence. Is it clear? Any more doubts?
And what are they? In
Start exploring so as I mentioned, basic and the higher level understanding. If you are having a data from 0 to 100, for suppose, you can bin it into 0 to 30. So the records what falls under 0 to 30 is a bin A. 30 to 60 is a bin B. And the other is bin C. It's not always you are splitting it into 3 equal offs, or it is not always that you are splitting half. There are many things need to follow while binning also. Maybe the data is less in this bin, or maybe there is a chance where I need to bin 0 to 10, 20 to 60. There is also chance. But based on that, you need to tweak the later part. And it's not always that you should get more accuracy with this model, with this setting. It depends on many things. As I mentioned, maybe the data set is like that. Even if you experiment with any model, you can't get that. Maybe you can, if it is 40, you might go to 50 or 60. It's not that you are doing something error. It's not that you can't achieve. As I mentioned, there are many ways to induce biases, where there are many ways to add weightage. There are many things like it's nothing like you should directly blindly fit the model and see the predictions. You can play around. So go through the documentation, do the research, and whatever you are learning here, don't stick with this. Like you need to know in and out about the function if you are going to fit. Like if you are fitting a logistic regression, if you are fitting it, what is happening as soon as you click on a fit? What is happening to that data? So where it is going? What calculations are being made? Where you can tune it? What you can induce from the code point of view? If some data comes up like this, what are the things you can handle while fitting this kind of data? It's not limited that you should do this. There are many parameters. There are many functions you can go in and check if this is usable, this is feasible, if we can use this, if using this, is it affecting really?
I see in the graph or the approach, like how can you decide model? What model we have?
experimented that. That is not
We
that.
have to get an idea, okay, like this, we have to apply this thing, this model.
So if it is
Then
if it is a classification,
can't apply
if it is a classification, start with basic classification model. If it is not working fine, like go for next difficulty.
Actually, we got a thought like regression based one. But when we applied really it got more efficient than linear.
Yeah, it is possible. So that's what.
Can't predict.
So see, it is not hard fast and rule that every model should give proper results to the same data. So one model might perform well with this kind of data. One model might perform well with this data. So again, a real life example where I was mentioning about this insurance thing. We used XGBoost, I guess, I'm not sure. So it's not that we directly used XGBoost. We did lot of experimentation based, many models we have done. So with a particular parameter tuning, with the particular tree number count, with the particular depth, we just finalized XGBoost was working fine. It is not that just after looking at, okay, I'll try XGBoost. It is not like that. So we tried experimentation with the basic model. We did whatever we can do. We tweak, we tune, but it is not performing. While improving, like it is performing. It is not that your modeling is wrong. It's that this data is more adaptable for this kind of what do you say, algorithm. So as you mentioned, if the efficiency is increasing when you are using other model, it is not perfect model. So if it is like that, this model is a universal model which will be used by anyone and it will give good results always, then there is no need of creating other algorithms, right? So why are there many algorithms?
Secretly we can't get
No.
what model we have.
No. You need to make your hands dirty. You need to deep dive into the code. You need to write. You need to iterate. You need to see. You need to experiment. Data analysis includes a lot of manual work also. Not always you need to rely on the scripts. And I did much manual work to make sure that the data is structured and it is ready to train. So that's what, like, you should not stick with whatever you are learning here. You need to go as deep as you can with that function or with that package or what it is happening, what you can see. So if this is the thing you can fit, change something and see how it is happening, why it is happening. If you are changing this, how it is affecting. Is it affected by model changing thing or if it is affected by the data, or see different types of behaviors, then only you'll understand. Okay, this is the thing where it happens. So in future, if something comes up, I can use, I can change or I can switch this, I can tweak this thing. You'll have an understanding. So it's not that you should stick with one model, you should experiment. Any other doubts?
Have you used this sensor fault prediction in real time? Or
No, I did a POC.
what is that?
I didn't get it.
No, what you said?
I did a POC, proof of concept, for a client.
Okay. Okay, what is the minimum records to consider to train a model? Is there any minimum records like that? Like,
It should not be 10 or 5 records, that I can say. But I can't say this is the least number of records because no one can say. The
okay.
data quality is good. Maybe 100 record also gives a better model if it is a good quality data. If it is having multiple patterns.
But in real time, it will be many variants, right? Data will be
Yes.
very variant,
Yeah,
right?
data depends on many things. As I mentioned about this genomic data, we used to have 40 to 50 records, but the columns are 3000.
Okay.
So it depends on domain also.
So did that model give good accuracy, like where you have columns more and like the rows less?
Yes, we are able to achieve something around 70 to 73%.
Okay. What is the accuracy of this sensor fault detection? Like which one you which classification you used?
So if I'm telling that, I'm telling you the answer, right? You please do it your end.
Okay.
Just explain the flow to. Just one second.
Okay, so to reiterate, if you are dealing with data analytics more, the major thing will be gathering the data, cleaning the data. As I mentioned, data will not always be a structured format. It will be an utmost unstructured format possible. You need to make sure clean the data and make it structured and collect all the features you can get for the data. Then only you can start like seeing how it is dependent or not. So sometimes it might also happen that you gathered all the data, but it is not useful. You need to drop it. It's not that you should use it just because you like invested more amount of time to see. But the thing is that can be used to do some story narrations. Maybe Power BI dashboards, if people are working on that, maybe they can see, they can say uh, to the stakeholders or anything that so this is the data, this is how it is, these are the things what we can achieve from this. Maybe with that dashboards or with those analysis, they might take some business decisions also to remove or something or to add something, to cut down something, to invest more on this thing. Maybe some improvement needed on any field or maybe any wastage they are doing with any, let's say, if it is related with something to invest more. So with that analysis, they can see, okay, we need to invest on this rather than this. We need to cut down this so that we can balance our finances and all. Oh, it's not that every record should be used in modeling, as I mentioned. So once the data cleaning is done, just try to analyze data. So what is it is speaking, like what the domain is, how it is related, is it really making sense to have these records? Is really making sense to give this column to the model or not? If modeling is not your part, you just want an analysis, you just want to give some insight, some information about data and make sure that the stakeholders are going to take some actions or take some calls based on the data, then it's okay to give whatever possible analysis you can give. As I mentioned, if there is a scenario where management is decided to cut the cost, why to cut the cost? So it doesn't the main question what they are going to ask is how does it affect if I am cutting the cost? It is not going to give any backstab for me. Like if I am cutting away the cost for it, I might lose my business. So that can be the question. So with this analysis, you can show that if you are putting something in this field or in this area, it doesn't make any sense. But at the same time, it might not helpful in the model. While you are building a model, if you are training a model, this field might not be useful there. But it is giving information while you are analyzing and giving a story for the stakeholders. With that, they can do like business action, which is much bigger thing. Yeah, so basically this is the pipeline where you gather the data, clean up, see what are the outliers, see if like record should be there or you really need to drop, think twice. And if you are dropping or if you are imputing or if you are adding something, make sure that you have a simple justification why you are doing that step. Which that like so these are the steps I need to follow. This is the distribution I need to no. Why what is the reason behind that step? What is the reason behind you are giving the distribution? What is that explaining to you? If just some person comes in and says what it is showing, then it should not be like that. It should say something. So that is how it should like. And again, it is not that you should do only these kind of plots or only these kind of steps needed to be done. You can do anything. It's not always strict. Like EDA is not a defined steps. Like the procedure what you need to follow is the same, which means gathering, collecting, exploring, then giving the model. But the steps inside gathering or the steps inside exploring, it is not any, like, what do you say, consolidated step that you should restrict yourself to do it. You are free to do anything. You are free to do you can play with the data in and out. You can do any analysis you can say. Maybe that analysis might give you some weightage, some idea once you do it. But as I said, you should have a justification why you are doing that, what it is showing. If it is not, don't do it. Simple. And it is more of experimentation. Generally, it is data science is not a straight way thing. It is always a experimentation and R&D. So if you are building an API using Java or anything, it is a straight line because you know what payload you are getting, what you need to retrieve, what you need to show to the end user. But here you are building a model. You are seeing how it is going to behave in the future when it is deployed. So it is not at all a fixed thing. So the data science always talks about experimentation, research, development, trials, like lot of trials needed. Like it is not at all a strict process that I can say. Any more doubts?